Now we are going through some kind of most difficult question ever encountered. Basically, it might look something like this: a test tube, okay, holding some kind of mercury column here. Okay, I'll just draw it here. So this mercury column, we have a distance of 8 cm here. The bottom of the tube is of course having an area of A, and there's an atmospheric pressure acting on this. Atmospheric pressure. So atmospheric pressure, you know that it's actually 76 cm Hg equivalent, okay? But depending on some books they use 75. So in this case, do you realize that if you were to be trapped inside, if there's a human being inside and you are pushing this mercury column is 2 cm, but in this case mercury column is not going anywhere, so your effort of pushing is called P1, and the atmosphere is going to push you inside to the left 76 cm Hg. So if you are pushing to the right and the mercury column seems not moving, you can safely to say that the system has reached equilibrium, meaning the mercury column is not able to going to the left or going to the right. So I can say my P1 is 76 cm Hg. Okay, with this in mind, I could write my V1 to be 8A. Okay, so the real question is, what if you position your test tube in such a way? Okay, so this one remain 2 cm mercury, and I'm interested to find out what actually is the length here. Call it H1. Well, it's not H1N1. Okay, so the atmospheric pressure is like this. The atmospheric pressure is like this. So do you realize that let's say if you are trapped inside and you are holding up to it, you realize that now the mercury is playing a role in pushing you down as well. So you have 76 cm Hg along with the mercury 2 cm Hg. If system is in equilibrium, we can say P2 equals to 76 plus 2, because you fight with two of them. Two of them are conspiring to fight you down. Okay, you are the one holding both of them. So if the system doesn't move, means you have the strength of 78 cm Hg for your P2. Okay, perhaps here I should write H2, you know. So V2, I'm interested to find out V2 so that I can find out H2, because H2 is going to times A. A is the area of the bottom. Okay, so for this case I want to use P1 V1 equals to P2 V2, and P1 V1 is 76 times 8, and P2 V2 is 78 times H2A. Just now it was 8A. Okay, V1 is 8A. So this side and this side, you know, I can use a different color. I can cut off the A, and I can do some calculation. I realize my calculation is H2 equals to 76 times 8 divided by 78. Okay, so you have a clearer picture of what happens when I do the calculation. Okay, in case you can't see it, just listen to the words that I've spoken if you can't see the words below. So the next thing is, we haven't finished. What if okay, you first of all, before we proceed, you should remember what I wrote just now, the one on top, especially here. You should remember this. We're not going to come back here for information, because the new page will have a system of tube holding like this. Okay, the tube holding like this, so your mercury seems to be here, and here is my H3. So there's an A at the bottom of the tube. Okay, the A. So I use my black pen again. So this is 2 cm Hg, no doubt. But do you realize that now you are standing on the mercury, and the mercury has no choice but to help you? So your pressure 3 along with the mercury is fighting with the atmospheric pressure. So can I just write P3 plus 2 cmHg is equivalent to 76 cmHg. So can I say P3 equals to 76 minus 2? Yes. So it's 74 cmHg. And how about my V3? My V3 will be H3A. And because of this, I can write P1 V1 equals to P2 V2. So therefore, my calculation should be based on, okay, this is not P2 V2, it's P3 V3. Let's go back a bit. Just now it was 76 for P1, V1 is 8A. So 76, 8A equals to 74 and H3A. Okay, so because of this, after some calculation, you realize that your H3 will have the value of, after cutting the A, so your H3 will have 76 times 8 over 74. You realize that your answer will be whatever your calculator presses. Okay.